MTBE or methyl tert-butyl ether is technically speaking not a 4-carbon molecule, but I added here, and you will see also in textbooks and in theory, that MTBE might be added in the C4 cut. And this is mainly because it is produced from isobutylene and methanol in order to make this ether. So what's an ether? It's an oxygen bonded to two hydrocarbon chains. And why is it so useful? Because there are a lot of chains, meaning that it will burn very efficiently, and because there is an oxygen here, you will get most of full combustions. So it is a very good additive. Actually, if you go there, you will find out the MTBE being branded as a good additive. 10% ethanol, 15% MTBE, those are common additives in gasoline in order to increase its flammability, or let's say technically their octane rating. MTBE is volatile, flammable, colorless, and almost not that soluble in water, much more soluble in gasoline. All oxygenated fuels reduce hydrocarbons in the automobile exhaust. So that's what I was telling you about. Because it is oxygenated, it will be reducing most of hydrocarbons. MTBE is a gasoline additive, increases octane number, and it's kind of controversial nowadays because it is actually found as, let's say, a contaminant in groundwater. So kind of legislation is passing through, avoiding MTBE to be used as a gasoline additive and increasing ethanol over this. Now, MTBE can be produced from the C4 cut, which is either obtained from the steam cracker or FCC. You already know that. MTBE is manufactured via the chemical reaction of methanol and isobutylene. And here you have it. Ethanol will be used as the greatest material to improve octane rating, then MTBE, then methanol, ETBE, and Ethane. We're going to see those later on. Those are actually related to the 5 or C5 cut. Methanol, you can find it from, you already know how to produce methanol. And in the US, you will see that MTBE production is very high because you gotta increase the quality of gasoline. So something around 200,000 barrels will be used for gasoline a day. And how do you produce it? This is a very easy process overall. It's not that complex. It's via the etherification of isobutylene. So you got etherification, remember, it's nothing more than you got methanol, which contains an OH group, and you got the isobutylene. What you're going to do is to try to add this to the molecule and make the ether. Now they get mixed, methanol, C4 cut, and the methanol recycled stream. They go here, and then they meet their recycle. This is overall recycle of the process, and this is overall recycle of the reactor. They are here, present here, they react and they form the ether mostly. MTBE will be present, as well as some C4 leftovers and some methanol. Then you bring it here, separate it for the reactor recycling. You set up the temperature for the finishing reactor. This essentially improves the yield of MTBE. Then you bring it here, add it with this recycle, the bottom of the debutanizer. This is rich in C4 cut, essentially butanes and so on, and this is rich in MTBE. So some is used in order to increase the yield of this column. The debutanizer is going to separate C4 and MTBE mostly. Now the C4 is treated via water scrubbing just to ensure that you're not losing all the materials, and then you send it, once you goes here inside, then you send it as, where is it? The methanol water separation. Okay, you send this as the raffinate. This is the organic layer, and then you send this to the processing of methanol water. What you want to do is to get separation of water and methanol. But anyway, that's a technicality. Let's continue with the MTBE, which is directly produced from this debutanizer. Because MTBE is very heavy, you're going to be able to separate it pretty easily. And MTBE is now ready for use.